subjected to various methods for the estimation
A bit louder.
0.20 grams of organic compound is subjected to various methods for the estimation of halogen and resulted in 0.15 gram of silver bromide. Determine the percentage of bromine in the given organic compound.
Now here our whole concentration is what is on what? One guy, right?
Yeah.
That guy is what? Bromine, right? So it's how simple it is, right? So in this case, what we are going to do here, Kairos method is what we are going to use. According to the question, right? Whenever you see these guys, what you must try to do first is to collect the data. Alright? First thing here. We have the mass of the organic compound, right? Not only that, we have the mass of the bromide. Is that also?
Yeah.
Now go to the question and also let me have the mass of the bromide. Given here, mass of bromide, right? Let me just bromine. This one is equal to mass of bromide, right? Of bromide. Let's go now. Yeah, what do you have for that guy?
ATG.
Huh?
ATG.
No, sir. Is that the mass or the atomic mass? Is which one? The atomic mass for this guy here, for bromine, is what? Is 79.904. That is the atomic mass. But when we round this all off here, we are going to have what? We are going to have what? 80. Are we okay here?
Yes, sir.
No, sir. This is not the mass. We are talking about what? This is for the atom. This is the atomic mass.
That's the atomic mass.
80.
For the atomic mass, right?
Atomic mass.
Now let's start with the question.
Molar mass.
Yes. Now molar mass of what? Now when you combine these two guys here, that means you must have the mass of silver, right? Yeah. And the mass of silver is what? It's 107.07 again. Alright? So when you add them together, you're going to have the mass of what? Of this guy here. That's silver what? Silver bromide. So in this case, that's why you're seeing what? You're seeing what do you have there? You have 80, right? Is that not so?
80 grams.
That is for what? For bromide, right? Next what do you have?
The molar mass of AgBr is 88.
Now we have 188. Alright? Are we with this one here? Hope it's clear, right? So this guy, we are going to use these guys. Or we use this guy. Anyone, either of them is what is correct. So are we okay here? Start giving the question, let me collect the data.
So 0.20 gram of organic compound is subjected to Kairos method.
Now look at this one here. What is the organic compound here? What is the mass of the organic compound? Mass of compound, right?
Yeah.
Is now equal to what do you have here? 0.20 grams. Let's go.
Subjected to Kairos method for the estimation of halogen resulted in 0.15
0.15
G of silver.
Of silver?
Yeah, bromide.
Of silver bromide, right? Of silver bromide. That we have what?
Determine the percentage of bromine in the given compound.
This one is just as straightforward, right?
Mass is 80.
That's good. The first thing that we have collected data, right? Next, look for their what? Their molar masses and atomic masses, right? All the units, guys, it is given to the question, right? So let's go to what next do we have here?
The atomic mass is
AR of what? Of bromine, right?
80.
Is equal to 80, right?
Then the molar mass
Now you have MR for what? For the compound, right? Is now equal to what? 188, right? Next, what I need to find here? Find the mass of what of bromine here. You have to find what the mass of what of bromine. Have you here? How can you have the mass of what of bromine? Mass of bromine here is now equal to now the atomic mass of what of bromine. This is your area of concentration, right? Therefore, the mass must be part of the play. The atomic mass of what of bromine, alright, all upon what? The mass, are we okay here? That's what the atomic mass of what the molecular mass of what of this guy, which is this man here. Are we alright? That is what? Silver what? Silver bromide. Multiplied by what? By this guy here now. So the compound. Are we okay here now?
Shortcut,
Sir?
Again, a shortcut.
This is the shortcut I'm giving to you guys now. Okay? Just pay attention and grab the person. Are we okay here? So we have what? Atomic mass of what? Let me say AR of BR, all upon here. AR or MR here of what? Silver bromide, right? Multiply by, and what do we have here now?
What is the MR?
Molecular mass.
MI?
MR, yes sir. Relative molecular mass. Are we okay here? Are we alright?
Yes, sir.
So we go. Now what do we have now, sir? 0.15, right?
Yes, sir.
So therefore this guy here is now equal to, and what do you have for this guy here?
180.
Now we have what? So you have 80, right? That is 80 all upon, and what do you have for this guy here? 188 here multiplied by 0.15.
So 80 divided by 188 times 0.15. We have 0.0638.
MR is equal to 0.0638,
38.
right?
Yes, sir.
Are we have to find this guy here?
No.
What are we have to find here?
From the question.
What are we have to find?
Percentage of bromine.
Percentage of bromine, right?
Yeah.
So, how can I have the percentage of bromine here? Percentage of what? This pen is equal to what our question now, right?
Yes, sir.
Have you gotten this guy now? You know what? You know the reason we got this guy? Huh?
No.
Because we are going to make use of that particular guy. Now looking at bromine here. Are we making use of this man here?
No.
No, we are going to make use of this guy again. But how are we going to make use of all of these particular guys here? Let's see this pattern continue. So I'll copy the 551. Good. And this percentage of bromine here is now equal to, what do you have?
31.9%.
I have 31.9%. Simple and straightforward.
No, you need for watch in the marker, not clear. Okay, clear. Problem two.
Estimation.
Sir?
In Carrier's method of estimation, halogen, 0.15 gram of an organic compound.
Now, mass of the compound, right? See, mass of compound, right? Mass of compound here is equal to what?
0.15 gram.
0.15 gram, eh? Yes, sir.
Gave 0.12 gram of AgBr.
Mass of silver bromide is equal to 0.12 grams, eh? Yes, sir, let's go, sir.
You say finally percentage of bromine in the compound.
Now, percentage of bromine. Percentage of bromine is equal to our question, right? But this is from Kairos method, is that so, sir?
Yes, sir.
Now, when you have this guy from Kairos method, the first that you must do here, you have collected data, right?
Yeah.
Next step. Now, look at the guy here. We must have the mass of our area of concentration. Are we okay here? So, therefore, but how can you have the mass of this guy here? First, you cannot have this mass of this guy here without having what? The molar mass, right?
Yes, sir.
What is the molar mass of this guy here? Is this one given to us in the question? Bromine.
ANS then.
Huh?
ANS.
ANS,
Yes.
No, they
right?
not give us.
So that's the
Yes,
answer,
sir.
right?
Yes, sir.
But you must know that always I have given this one to you. That the molar mass of bromine here is what? 79.904, right? Always. That's fixed, okay? And for this guy here, for silver, the molecular mass here is equal to what? We have 107.7, right?
Yes, sir.
Now, when you get this one off now, then you add these two guys together. Okay?
Yeah.
Now, we must have a total. And what is that? You now say what? Silver here plus what? Plus bromine, right? Now, what is the atomic mass for silver here? 79.9, right?
Yes, sir.
Plus 107.7. And what is that? When you add everything here, what do you have?
Should be 187.694.
Now we have 187 point what?
694.
694, right? So therefore this is 188.
188,
Are we okay now?
Yeah.
Good. So therefore everything there is what? Is 188. So what do we do here in this case now? We say mass of what? Mass of bromine, right?
Yes, sir.
Mass of bromine here is now equal to, how can you have the mass of what of bromine here in this case? I've given you the formula, right? Okay?
Yeah.
That's the atomic mass of what of bromine. Is that also, sir? Now, see, atomic mass of bromine, right? All upon. Next, we have what? We have the compound. Is that also, sir?
Yeah.
Good. Now, you have what? You have the atomic mass here, or molecular mass here, molar mass of silver bromide. Multiply by what? What are we finding here?
Mass of the compound.
Now, see the mass of what of the compound, right?
Yes, sir.
And what is that?
0.15.
Mass of this guy here. So, what's the mass of the compound? Mass of what? Mass of this guy,
Yeah,
right?
silver bromide.
Now, we have what? You have silver bromide. Is that also, sir?
Yes, sir.
Now, that is all. The moment you're able to interpret this area, then you're okay. Are you okay here?
Yes, sir.
But we are finding what? The mass of what of bromine, right?
Yes, sir.
So, say mass of bromine is now equal to atomic mass of bromine. What is that now? Atomic mass of bromine is what? Is 80, right?
Yeah.
All upon molar mass of what? Of silver nitrate, silver bromide. What is that now?
188.
Now we have 188. Everything combined, right?
Yes, sir.
So we say multiply by the mass of this guy. What do you have now?
0.12.
Now I have 0.12. So therefore the mass of bromine
is 0.
I have
0.0511.
0.0511, right?
Yes, sir.
This is mass. The unit of mass is what is gram, eh?
Yes, sir.
Not at all, but we are asked to find what percentage of what of bromine. Is that also, sir?
Yeah.
So find the percentage of bromine is now equal to, now we are putting the mass of bromine, right?
Yeah, mass of bromine.
You see what? Say mass of bromine divided by what? By the mass of the compound, right? Mass of compound. Multiply by what? By 100. Why? Because we are now talking about what percentage, right?
Yes, sir.
So we go. Percentage of bromine is now equal to, what is the mass of bromine? 0.0511, eh? All over mass of the compound. What is the mass of the compound here? What's the mass of the compound?
Mass of the compound is 0.15.
15, right? 0.15 multiplied by 100. So therefore, we can now say percentage of bromine is now equal to, what do you have?
34.1.
34.1%, right?
Yeah.
That is all that you are asked to find. That's what they wanted. Are you here?
Yeah.
Good. So we move, eh?
No, sir.
Okay, we go. For the first question here, the first that you must do here, after we have collected the data, next, if you like, you can convert this one to mil, right? To liter. You can convert volume to liter. Alright, if you like to. If you like, you can use that volume. After that, yeah, and most cases what at STP, right?
Yes.
Yeah, also, sir.
Yes, sir.
STP, standard what? Temperature and pressure, right?
Yeah.
Now, we know the standard temperature always is what? Is 273 Kelvin. And the standard pressure is what? Is 760 millimeter mercury. They can give you just one temperature. But you know that this guy is what? The standard temperature is what this guy, right? So that's why you look at what? Standard temperature and pressure. And also here, for the standard volume, we know that it is what? 22400. Is that also, sir? You have in terms of what? Milliliter, or in terms of mil, and also in terms of what? In terms of this guy, liter. Right? But I mean, I'll let you take this guy here. This guy, you must have them upstairs at any time. You must sleep with them, wake with them, die with them. Alright? Because you know you're going to see questions, right? Yeah. But usually these guys, you're going to see them a lot during your test, your exams. Sure. So, next step here, this was the general gas equation, right? Yeah. Are you okay here? Yeah. That is what? P1, V1. Is that also, sir? Yes, sir. All upon what? All upon T1. But remember here, we say in terms of what? In terms of the STP, that's what the standard temperature and pressure. That's also, sir. For us to find out the volume here, what we do here? We must take these guys. That is what? Equal to now, I can say what? P0, I'm okay here, and then you have what? You have V0, all upon what? All upon T0. I'm okay here? Now, next step here, We have to find this man, the volume, right? What do we do here? Make this guy the subject. Or let me say cross multiply for you to understand better. When you cross multiply, we're going to have what? We're going to have V0 multiplied by what do you have now? Let me just say T1 into what? P0 here, V what? V0, right? Are we okay here? Must be equal to, and what do you have now again? You have what? You have T0 here, and you have what? You have P1, V1. Is that also sound? Good. But mind you, this guy, common mistake here. Don't say I should multiply this guy, and this guy. No, but just know that you are multiplying everything here. This guy times this guy, this guy times this guy. Are we okay here? But we have to find V0. To find V0, we divide both sides by what? By T1 here, P what? P0. Are we okay here? Okay. Here also by what? By T1 what? P0. P0. Are we cool here? Yes, sir. Mind this guy and this guy will reduce to 1, eh? Yeah. This guy and this guy also will reduce to 1. We are left to sort now. V0 here is equal to T0 here multiplied by what? By P1 here multiplied by what? By V1 all upon, you have T1 here multiplied by what? By P0. Now, come on here. You know what is this man here? This guy here, mind this is the volume at STP that you're trying to find out, right? Okay. And after which now you're going to find the mass of what? Of the nitrogen. Are we okay here? Yes, sir. So let's say, what do we do here in this case? This guy here, T0 is what? Is the original temperature. That's why I'm putting what? 0 here. That's the original temperature, which is what? 273. Substitute now. Are we okay here? For the mass method. And this T1, this P1 that you're seeing here is what? Is the pressure after you have gotten what? Or after you have subtracted what? For you to have what? The actual temperature. Mind you, always for the mass method there, we have what? We have a temperature given to us at the end point. Alright? Like the temperature at what? When this temperature is, sorry, the pressure when this temperature is what? Is equal to this. Are we okay? Are we okay here? But when you go to policy, you're going to see them. Are we okay here? Yeah. So in this case, that's the pressure you're going to put here. But mind you here, if you have two pressure, you must subtract the pressure. Are we okay here? Now, this guy is what? The volume given to you. And this guy is what? This guy is what? It's the temperature given to you, right? Yeah. And this P here is what? Is the standard pressure, which is what? 760 millimeters mercury. Or Pascal, whichever the case may be. But you look at the atmospheric pressure. So if you have the pressure here, you must consider what the atmospheric pressure. You know the atmospheric pressure here? No, you know, right? When you see the problem, they can see the atmospheric pressure. Are you okay here? Sure. Let's go to the problem now. No, we're going to have them when we solve the problem. Okay. Problem. Let's go.
So in Dumas method of estimation.
Yes, sir.
Of nitrogen, 0.3 gram of an organic compound.
Now 0.3 gram, right? Now we have the mass of the compound now. Is that what 0.3 gram, right?
Yeah, of an organic compound.
Now mass of compound is equal to what?
0.3 gram.
3 gram, eh? Let's go, sir.
Of an organic compound, yes, 50 mil.
Yes, sir.
50 mils of nitrogen collected.
Volume.
Collected at 300
volume
Kelvin.
V1, eh?
Yes, sir.
Is equal to what?
50 mil.
50 mil. Yes, sir.
Collected at 300 Kelvin.
Now, temperature given to us, right?
Temperature.
Temperature.
Yes.
I'm coming, sir.
300 Kelvin temperature.
Temperature T1 is equal to what?
300 Kelvin.
300 Kelvin. Yes, sir.
And 750 millimeter pressure.
Now, pressure is there. Is that so, sir?
Yes, sir.
Now, pressure here, we say atmospheric pressure, right?
Yes, sir.
Pressure P here is now equal to what do you have?
Pressure is 750 millimeter.
715 millimeter mercury.
Yeah.
Yes, sir, we go, sir.
Calculate the percentage composition of nitrogen in the compound.
Now, percentage of what?
Composition
of nitrogen, right?
Yes, sir.
Yes, sir.
In bracket, aqueous tension.
Yes, sir.
At 300 Kelvin.
Thank you. Aqueous tension, right?
Yes.
In what? And this temperature, which is what 300 Kelvin, right?
Yes.
Don't you can hear?
Equals to 50 millimeter mercury.
That is your pressure. So what you must do here? For you to know that atmospheric pressure, you must what? Subtract this guy here. When you subtract 715 here, right? Atmospheric pressure here is now equal to what do you have now? 715 minus 15. That gives you what? 700 millimeter mercury. Is that so, sir?
Yes, sir.
Good. Let's go, sir. At STP.
Yes, sir.
At STP, what do you have? You can see what? At STP, Are you right here?
Yes.
What's the pressure here? Pressure here, P2 now, or P0 here is equal to what? 760 millimeter mercury. Are we okay here? At pressure again, at STP here, we have what? We have temperature. Temperature, that is T0 here, is now equal to, you have what? 273, right?
Yes, sir.
273 Kelvin. Are we okay here?
Yes, sir.
Let's look at V0 now. Volume, we know that volume is supposed to be that guy, right?
Yeah.
But volume here, V0 here is equal to, let's find this guy. So, with this guy here, we use what? The standard temperature and what and pressure. Let's use the equation of what? Of the general gas equation, right?
Yes, sir.
Are we clear? Using here, we have what? We have P1, let me just put 0. P0 here, V0 here, all upon what? All upon T0 equal to, we have what? We have P1, V1, all upon what? All upon T1. Are we clear?
Yes, sir.
Multiply the guy and the guy. Are you right here? That is what? T1 here multiplied by what? By P0 here times V0 equal to, and what do you have again? T0 here multiplied by what? By P1 here times what? Times V1. Are we clear?
Yes, sir.
But the guy is what you want to find. Find this guy here, what do we do here? We say this V0 here is now equal to, now we have what? We have T0 here multiplied by what? By P1 multiplied by what? By V1, eh?
Yes, sir.
All upon, what's the guys that are closer to this guy here?
T1.
They have T1 here
P0.
times P what? P0, right?
Yes, sir.
Go to the question and substitute the values now. Are we getting the concept here?
Yes, sir.
Simple and straightforward, right? So we go.
Put your phone that number.
V0 is equal to, what is T0 now? T0 is what? 273, right? 273 multiplied by, now we have what? We have P1. What is P1 giving to us in the question here? We have gotten P1 as what? As 700, right?
Yes, sir.
What is subtract what? The aqueous tension here. And this guy, what do we have here?
It's 15.
We have 700 times V1. The volume, what do you have for the volume here?
50.
You have 50, right?
Yes, sir.
All upon, now what do you have T1? What is T1 giving to you?
300.
You have 300 here multiplied by P0. What is P0 now? Pressure is what? 760. And V0 now is now equal to, is that simple question was right?
Divided by 300.
What's it?
41.90.
Confirm, man. Let me confirm.
41.9078.
Confirm?
Yes, sir. 41.91.
41.91.
91. Yes, 90789.
90789.
789.
Eh?
Yes, sir.
Okay. Let's say 79, eh? 1, 2, 3, 79. Yes, sir. That's all, eh?
Yes, sir.
Volume here in what? Let me see this was ml. Yes, sir. Well, are we have to find the guy here?
No.
This is the guy. Now you're going to find the mass force of nitrogen. For you to find the mass of nitrogen here, this volume here divided by what? What's that? This constant here. Are we okay here? Multiply by what? By the molar mass of nitrogen. What is that? 28, right? You know what is 20? You know why it's 28? Because nitrogen is what? Is 14, right? You understand, sir?
Yes, sir.
N2 here. At 2 times 14, what they are?
28.
28. That's the problem. That's the, sorry, the reason.
Okay.
Let's do this one, right? Is this, I hope this one is in what the percentage here, the volume is needed. Because you have to find what the mass of force of the compound, right?
Yes, sir.
That is the mass of force of nitrogen at what? Sorry, the mass of nitrogen here, right? At STP. And what is that? That mass here should be can be gotten here when you divide the volume at what? At STP. Now this volume is what? At STP, right? That's what we are gotten now. Divided by what? By this constant volume. Now at STP here we have this guy again. You understand? Mil. So when you divide these two guys here and you multiply by what? By the molar mass of nitrogen, which is for 28, then you are gotten your mass. Go to what? Go to the percentage now and say what? That mass which you have gotten, the mass of nitrogen here, you divide by what? By the mass of force of the compound, and what happens when you multiply by what? 100 or by 100, right? Because we talk about the percentage. I hope this one is clear, right? But we are going to look at more problems because we can understand this better. Are we okay? Let me just take this guy off. Yeah, we need this mass, right?
Yeah.
Good.
Open.
Now we go again, eh?
Yeah.
So therefore, what do you have now? We have to look at the mass of what? mass of nitrogen, right?
Yes, sir.
Is now equal to, how can you get the mass here? Volume at what? At STP. Are we okay here? Of what? Of N2. All upon here, you have what? You have this guy here, which is 22400. Are we clear?
Yes, sir.
Excuse me, let me just take this one off. So we can say what? Volume of what? Of N2 at STP all upon. Now you have what? You have this constant, right? 400. Are we going to use this guy here?
Yes, sir.
Multiply by what? By the molar mass of what of this guy? Relative atomic mass, right? Now see what? Relative atomic mass of what? Of N2. Are we going to use this guy here?
Yes, sir.
Now the mass of this guy here is now equal. Volume of what of nitrogen at STP is what?
It's 49.90.
49?
41.9079.
79 divided by what? 22400. Multiply by what? Now you have what? You have 28. Why 28? Look at this man here. We pay attention here. Now 2 times relative atomic mass of what? Of nitrogen, right? Now what is that now?
It's 28.
Now we have what? Now 2 times what? 14, right? Is equal to what?
28. Why 2
28.
times 14?
Yes, sir. Nitrogen gas here is what? N2.
Okay.
How many nitrogen do we have there now?
2.
It's, let me write it AR. This is what MR. Relative molecular mass. Are we cool now? Are we okay, right? So therefore we go. Now everything now, what do you have now?
It's we have 41.9079 divided by 22,400 times 28 is 0 point.
0 point.
Yes, 0.05
05
238.
238,
Yes, sir.
0.05238 now, right? This is 234 grams, eh? Are we okay here? Now this is not what we are asking for. We are asking for the percentage of what of nitrogen, right? Having a percentage now, percentage of what? Of nitrogen gas is now equal to, and what do we have now? Mass of nitrogen, what is that now? 0.0524 divided by the mass of the compound, right? That is what? 0.3. 0.3. And what is that now?
Times 100.
Sorry, times 100. Now we are times 100. Now what happened now?
17.461.
Percentage of what? Of N2 here is now equal to 17.46.
1625.
1625, eh?
Yes, sir.
4616. Let's say 16, right? Now you can answer this way. But before that, you can use the answer here. Make sure you show that's working, eh? This one can be what? 17. You can leave this one is okay. Okay, yeah?
Yes, sir.
You can say what now? 17.6 now, 0.5 now, yeah, okay. You can say what? 17.46, yeah, okay. You can say 17.462, yeah, still okay. So how do you want me to this guy here?
17.46.
Let me do that at 17.46, right? Grams. Are we okay here now?
Yes, sir.
That is all. Sorry, percent. This is percent. That's all, eh?
Yes, sir.
Hope you see that. Is that also? Good. Let's take it out. The mass method.
So problem 2.
Yes, sir.
0.30 gram.
I have mass, eh?
Yeah.
Mass of the compound here. Mass here is equal to
0.30 gram
30 grams
of an organic compound give
Yes, sir.
30 cm cube of moist nitrogen gas.
Now 30, that's the volume, right?
Yeah.
Volume V1 is equal to what?
30 cm cube.
Centimeters cube, eh?
Yeah.
Let's go.
Of course, of moist nitrogen gas.
Yes, sir.
As 290 Kelvin.
290 Kelvin, right?
Yes, sir.
That is temperature, eh?
Yes, sir.
Temperature T1 is equal to what?
290 Kelvin.
290 Kelvin. Yes, sir.
And 745 millimeter mercury pressure.
Now, pressure, right? Pressure P is equal to
745.
745 millimeter mercury. Yes, sir?
Pressure. Calculate the percentage of nitrogen using Domas method.
Percentage
Domas
of
method.
nitrogen is equal to what our question, right?
Yes. Given aqueous tension.
Now aqueous tension, yeah.
At 290 Kelvin equals
Now
to
aqueous tension is
12.7.
equal to what? 290 Kelvin, right?
Yeah, equals
That's
to
the temperature, yes.
equals to 12.7 millimeter.
Now you know you can have always for this aqueous tension here. Always. You have a pressure here.
Yes, sir.
Now look for the atmospheric pressure here. So for the atmospheric pressure here is now equal to what do you do now? What is the pressure given to us here? Take that pressure, right? 745 minus the aqueous tension. What is for the aqueous tension?
Aqueous tension.
What is the pressure we have for the aqueous
is
tension?
290 Kelvin equal to
Yes.
12.7.
They have 12.7, right? When you subtract this guy, what do you have?
745 minus 12.7 is 732.3.
732.3,
0.3.
right?
Yes, sir.
Millimeter mercury. This pressure is what you're going to substitute into your formula. Are we okay here? Are we okay?
Yes, sir.
Now you have got all of these values. But what I want you to observe, whenever you have a problem like this, you know what you can observe here? You have a volume here.
Yeah.
What do you have here? Pressure is here, right?
Yeah.
And what the temperature is what is present. You don't know, sir.
Yes, sir.
Then you must introduce something. Which are the original? Are we okay here? We're looking at what at STP, right?
Okay.
Standard what? Temperature and what and pressure. Are we okay here?
Yes, sir.
We say at STP. Are we clear? Now, what do you have first? Volume, eh? Let's ignore volume. Now, say volume. Okay, let me just write volume. Let me just ignore volume. Volume here, that is V0. Original volume is equal to what our question. You know why? You know why we are saying this is our question? Because we have to get the volume. Because when we go to find what? To find the mass of what of the nitrogen here, we are going to make use of what of volume. Are you right? That is this volume at what at STP all upon what? All upon that constant which is what? 22400. Are you right? And we multiply by what? By the relative molecular mass of what? Of nitrogen now. It's clear, right? That's the reason why we are making this guy to be our question, because this guy is not known in this particular area. But here what he found as well as the standard temperature, right? What is the standard temperature? Temperature, that is T0, right? Original temperature is equal to what?
273.
Always 273 Kelvin, right?
Yeah.
And also our pressure, original pressure here, P0 is equal to what? 760 always. Standard pressure, right?
Okay.
Millimeter
That's the
mercury.
original pressure.
Always standard temperature and pressure. The standard pressure is what? 760
Millimeter.
and the standard temperature is what? Is this guy, right?
70.
Are we okay here? We move. Using here, we have what we call as well as the general gas equation, right? I don't know if we can see from this point.
Yeah, sure.
Using here, we have what? We have P0, V0, all upon what? T0. Are we okay here?
Yeah.
Equal to, we also have what? We have P1, V1, all upon what? All upon T1. Are we okay here? Good. We move, eh? But we need these values, right? Except what? P0. What do we need now? We can make what? P0 the subject here.
Yeah.
And how can we make P0 the subject here now? Of course, we can cross multiply, right?
Yeah.
So when you cross multiply, for you to understand better, we say we have what? We have T0 here multiplied by, and what do you have over here now? P1, V1, eh? But mind you, when the cluster, it means we are what? We are multiplying, right? Equal to, here again, we have what? We have T1, eh? T1 here multiplied by what?
P0.
By P0 here multiplied by what?
V0.
By V0. But this man is our target.
Yeah.
Are we okay here?
T1 P0.
So therefore, what do we do? Divide both sides by what?
T1 P0.
T1 P0, yeah, as well as T1 P0, eh? What do you observe here? This and this will reduce to 1, eh?
Yeah.
This and this will also reduce to 1. What do we left with here now?
V0.
V0 here is now equal to, and over here, what do we have? We have T0, we have P1, we have what? We have V1, eh? All upon what we have what? We have T1, we have what? We have P0. Are we clear? Good, so therefore we now say what? V0 here is now equal to T0. What do you have for T0 here? 273 here multiplied by P1. What do you have for P1? Look at the P1 here.
It's 7.
Alright?
7.
Now we have 732.3 times V1. And what do you have for V1 here?
30.
Now you have 30, right? All upon T1. What is T1 here?
290.
You have 290 multiplied by P0. What is P0? 760. So therefore we end up having V0 to be equal to, what do we have?
27.21.
Everything here? 27 point what?
212.
212. Volume is measured in what? Centimeters cube. That's also centimeters cube. Are we clear? Let's go. But we are not asked to find the volume. But without the volume here, we cannot find what? The percentage of nitrogen, right? Because we also got what? Mass of what? Mass of nitrogen. Is that also, sir?
Yes, sir.
Is now equal to, for instead of the mass of nitrogen here, it means what? Volume, eh? Say volume of what? Of nitrogen here at what? At STP all upon here. Next what we have? This area is too small. Mass of nitrogen is equal to, we have what? We have volume, right? Volume of nitrogen here at what? At STP. Are you okay here? Now, divided by what? By this constant, which is 22400 multiplied by what? By 28, right? Or let me say molar mass of what? Of N2. Are we clear? Now, so therefore mass of what? Mass of N2 here is now equal to volume of what of this gas STP. What do you have here? 27.212 all upon what? The constant, right? Now multiply by what? 28. Because this is 2, right? And nitrogen here has what? Atomic number of 14. 14 gives you what? 28. Are we clear? Now we say what? Mass of what? Of nitrogen here is now equal to what do you have?
1.905.
1.905, eh? That is the mass. We say M, we say grams, eh? Now when you have to find the percentage here, for this percentage here, we can now say percentage of what? Of nitrogen here.
Oh, excuse me, sir.
Yes, sir.
27.212.
Yes, sir.
Divided by 22,400.
Yes, sir.
Times 28.
Yes, sir.
It's 0.034. Sorry. Look at it.
Yeah,
0.034.
4 grams, eh?
015.
034.
0.03415.
402 now, eh?
Yeah.
Okay, 40. Let's say 40 grams, eh?
Okay.
Now, percentage of nitrogen is now equal to, what do you need here? You say mass of nitrogen upon, now we have what? That's what we have here, mass of the compound, right? We say mass of what? Of compound multiplied by 100, right? Now, so what do you do here now? Check this work, then we continue. Because there's no space, right? Percentage of nitrogen is now equal to mass, eh?
Yes, sir.
We have mass
Of
nitrogen, eh?
Yes, sir.
At STP, eh?
Yes, sir.
All upon mass of what? Sorry.
Compound.
Mass of compound. Multiply by 100.
Yeah.
Are we okay here? We are multiplying by 100 because we are talking about what? Percentage, right?
Yes, sir.
Percentage of nitrogen here is now equal to mass of nitrogen at STP. What is that?
Mass of nitrogen is
0.0340. All upon mass of the compound is what? 0.30 multiplied by 100. Eh? This guy here is now equal to, what do you have? You have 11.33%.
Yes, sir.
That's all.
7.33%.